Now, next method, see, this is a present linked list with 3 nodes. Now, I want to insert new nodes in this one. Where I want to insert, I can insert anywhere. But suppose always I want to insert at the end of a linked list. That a new value that I want to insert is 9 and I want it to be inserted here. So we know very well that for inserting a new node at the last, we should take a pointer and traverse till here, then we can insert a node. But when you are repeatedly inserting at the last only, then one suggestion is we can maintain one pointer called last upon the last node. That will help us inserting. How? Let us see. I want to insert a new value that is 7. So using a pointer, create a new node, insert the value, make this as null. Then last next should point on this one and the last should move on to the new node. This is how we can insert a new node. Let me insert one more node and show you. I want to insert one more node that is 15. So create a new node with a temporary pointer t, insert the value 15, make this as null, make last next point on this one and move last to new node. So in this way you can go on inserting at the last. So with the help of pointer last, we can insert it at the end of a linked list in just constant time because we don't have to traverse the linked list. This is possible if you are always inserting at the last. Then let me show it from the beginning. Suppose I have just one node, 8. Then where first is, this is the first node, so first will be here. Then where last should be, last should also be on the same node. So if there is only one node, then both first and last should point on that same node. So this is a special case that we have to handle. Now let us add something to this. Create a new node with a temporary pointer t and insert the value, make this as null. Now last next should point on this t and bring last on the new node t. Now one more case I will show you. If suppose there are no nodes, then both first and last should be null. When there are no nodes, initially they must be null. Yes. So when we are creating first node using a temporary pointer t and inserting a value, then that time we should bring first upon this node as well as last upon this node. So this is the special case that we have to take care, that make both first and last point on that new node. Then afterwards you can go on creating the nodes and with the help of last pointer. So let me write down the code for doing all this. Now I will write down a function called insert last. Insert last. So let us call the function as insert last. So insert last means it will not ask where to insert it, right? So just it will take the value that we want to insert. So let it take the value x. Now this function will insert a new node in a linked list that is at the last. So let us see how we can do this one. First of all, create a new node with the help of temporary pointer t. Okay, node t, assign new node. New node is created. Then assign the value x here, whatever the value that you are sending. So t's data should be x and make t's next as null. So t's next as null. So this is null. So a new node is ready. New node is ready. Now we have to look at the cases. Are there any nodes in the linked list or linked list is empty? There are no nodes. How we can know that if first or last both any one of them is null, then it means there are no nodes. This is the first node. So let us check that condition. If first, that is pointer first, is equal to null, means there are no nodes in the linked list, then make first as well as last as a new node t. So it means I will create it here separately. Suppose this is the first node, then both first will come here as well as last will come here. So this is the situation we have handled if the linked list was already empty. Otherwise, the repeating steps. So always what we were doing. So what we were doing, make last next point on t. Make last next point on t. Then move last to new node. Move last to new node. T. This is a function. This is the insert function which will always insert at the last, and it will always insert a node. There are no positions, so there is no question of invalid position. Always it will insert a node at the end of a linked list. If there are no nodes in a linked list, then it will make that as first node of a linked list. Otherwise, it will insert at the last. I will write on few function calls for creating this linked list. I'll just write the calls here. So first call, I will say insert last 8. So this is the first node 8. So both first and last will be pointing here. This is the first one. No doubt T is helping here, but I am not showing T here in picture. Then again say insert last, value is 3. So 3 will be created here, and this will be pointing on this one, and last will be on this one. Then again say insert last 9. So 9 will be created, 3 will be pointing on this one, and this becomes a last node. So in this way you can go on calling this function as long as you want to insert the element. As many elements you want, you can insert by calling this function. This function is for just inserting one node at the end of a linked list. And it works even the linked list is empty. So it always guarantees to insert some node in a linked list. There are no invalid indices because we are always inserting at the last. So by using this procedure, we can create a linked list, and then we can perform all other operations on linked list, like adding all the nodes, finding maximum, reversing a linked list, and so on. So I'll be using this function in my program for creating linked list.